السلام عليكم ورحمة الله وبركاته. This is lectures for numerical methods. It's lecture number 8. We finished before chapter 1 about solution of nonlinear equation, chapter 2 solution of system of linear equation, chapter 3 curve fitting, chapter 4 is interpolation. Now we are in chapter 5, numerical solution of integration. Numerical solution of problems for integrations. So what's the integration? We know before integration is the inverse of differentiation. We take many methods for integration. Now, if I have a problem, very complicated problems, how to integrate it without making in method for integration, we have a methods numerical, very easy to calculate the integration. So to calculate numerical integration, so numerical integration on strategy of replacing complicated function or tabulated data with some approximating function. We know integration from a to b f of x dx. We make approximate for the integration by a polynomial called Pn of x. So instead to integrate f of x, we integrate Pn of x. Pn is a polynomial of degree less than n. N is the number of points which we will given. The first rule for numerical integration is called trapezoidal rule. For 2 points, we can calculate it first. If I have x0, y0, first point, second point is x1, y1. Make it interpolation before we make the down this table x0, y0, x1, y1, and the first difference is delta 1. So the polynomial is y0 plus delta 1. You remember k here is called s. So what is s equal x minus x0 over h. Instead to differentiate with x, we differentiate with s. So make substitution. First point is x0, second point is x1. If we put x equal x0, we get s equal 0. If we put x equal x1, we put s equal 1. And ds is equal dx over h, i.e. dx equal h ds. So after substitution, I trapezoidal equal h over 2, it meaning I trapezoidal, h over 2, y0 and y1. What's meaning by y0 plus y1? H over 2, h was h difference between 2x, h equal x1 minus x0. So I trapezoidal equal h over 2 first point plus last point or second point here, because I have 2 points. If we make a general after that, we will see is another rule. But first trapezoidal is difference between x over 2 between brackets first y first point plus last point y1. It's called trapezoidal rule. If you want to know how the trapezoidal rule equal h over 2 y0 plus y1, here is the table for interpolation. Up here, down makes the polynomial. After that, make the integration. So integration equal y0 plus delta 1 s equal x minus x over h. And make many substitution, we reach to I trapezoidal equal h over 2 y naught plus y1. We have a numerical integration, not exact integration. So we have difference between numerical integration and exact integration. How to calculate this difference? We say that is error. So we are now in trapezoidal rule. So we estimate the truncation error for the trapezoidal rule. ET means error for trapezoidal. So integration x naught to x1 y dx minus h over 2 y naught plus y1 is the exact integration minus the rule or numerical integration. The difference gets the error. By mix up tail expansion for we get error equal minus h power 3 over 12 total times y naught double dash. What's y naught? Make y 1 and make y differentiate first, differentiate second, and substitute y naught at x equals c naught. H x1 minus x naught power 3 over 12. So remember this is the error. The error is equal minus b minus a over 3 b. Last second point a. So from a to b. So b minus a like x naught x1. So x1 minus x naught. So p minus a power 3 over 12 y naught double dash. That is the truncation error for trapezoidal. The second method is called the Simpson 1 over 3 rules, because we have 1 over 3 and 3 over 8. We will take only 1 over 3 rule. Simpson's 1 over 3 was different between Simpson and trapezoidal. The trapezoidal between 2 points. Simpson we take 3 points. What is 3 points? X naught y naught, x1 y1, x2 y2. There is 3 points. X naught, x1, x2, y naught, y1, y2. That's the we make the polynomial x naught, x1, x2, y naught, y1, y0. Make the polynomial for interpolation. By the first column, delta 1, delta 1, delta 1 between y1 and y naught, delta another one between 2 and 1. What is the difference? Second column between delta 1, delta 1, delta 1, the delta 1, delta up is 1, down 0, 1. What makes 0, 1? Between y1 and y0. Delta 1 I. First difference between 2 and 1, so it's called 1, 2. And that's the second difference, delta 2, O2, between delta 1, O1, and delta 1, 1, 2. So delta 2, second difference between O2. What's meaning O2? Between x naught and x2, or between y naught and y2. So make this interpolation, we make the polynomial and substitute. How to substitute it? We make it before like trapezoidal. Put s equal x minus x naught over h. So dx equal h ds. So at x equal x naught, s equal 0. And x equal x2, s equal 2. So the integration, instead x naught and x2 so is between 0 and 2. We put the table. What's the table? First, y naught plus delta 1 difference 1 s. Difference 2 s minus 1 over vectorial 2 ds. What is delta 1 between y1 and y naught? What is delta 2 between delta 2 minus delta 1? Substitute and integrate, we get the result. Trapezoidal 1 over 3 is called h over 3. So it's called 1 over 3, h over 3. Y naught plus 4 y1 plus 2 y2, because we have 3 points only. What's that meaning? 4 y1, so y naught is the first point, y2 is the second point. So First point, we end point 4y1. What's 4y1? 4y is odd 1. So we have to save this formula to know what is the Simpson third rule. So integration third rule equal h over 3 y naught plus 4y1 plus y2. Also calculate the local truncation error of Simpson. We get before error for trapezoidal is equal minus h power 3 over 12 y naught double dash. For Simpson minus h power 5 over 12 y naught force dash. So meaning force derivative of y naught. Force derivative of y at y equal y naught. That's meaning that. So equal minus b minus a power 5. So because h is equal b minus a. So equal minus b minus a over power 5 over 12 y naught force derivative. We proved before the trapezoidal rule, but we proved only for 2 points. What was it? I trapezoidal equal h over 2. Take care, h over 2 y naught plus y1. So first point plus last point. But if we want to make generalized trapezoidal, what mean by generalized? Many points, n points. N points may be odd or even, any points. And the distance between 2 points is equal spaced. I mean, difference between first point, second point is the same, second point, third point, and the same, and so on. So h, we know that h, before h is equal b minus a, here h equal b minus over n. What's n? Is the number of points. So I trapezoidal, save this rule quickly, or save it exactly, is equal h over 2. What's h? H equal b minus a over n. What's b? Last point. What's a? First point. So h minus a b, h is equal b minus a. So I trapezoidal equal h over 2 between two brackets. Take care from that. First point y, so called y naught, plus last point for y, yn. So first point plus last point plus 2, all points inside. So I trapezoidal equal h over 2 y naught plus yn plus 2 summation all points yi. Okay, we will explain it by different examples. We illustrate that by examples. Example 1 about trapezoidal rule. What says the example? The example says that use the trapezoidal rule. Again, what's the trapezoidal rule? The trapezoidal rule, I trapezoid, I meaning integration by trapezoidal equal h over 2 between two brackets, first point plus last point plus 2 the other points. So use trapezoidal rule to calculate the approximate value of the integration. Integration from 1 to 3.4, 2 over square root x plus x dx. About this integration, complicated. By numerical, it's very easy. We say that taking n subinterval, taking 8 meaning n. So between hx is 8 interval. What meaning of the interval? So first, we will have to divide between 3.4 to 1 to 8 interval. N equal 8, so calculate h. H is the difference, number of interval. H equal b minus a. What's b? Last point 3.4. What's a? Is 1. So take h is equal b minus a. Okay. So first calculate h. H is the number of intervals. We say the number of intervals is 8. So h equal b minus a over 8. B is 3.4, A is equal 1, N is equal 8. So 3.4 minus 1 over 8 is equal 0.3. So we divide the intervals here, beginning by from x equal 1, each interval increase 0.3. So second 1.3, third increase 0.3, 1.6, 1.9, 2.2, 2.5, 2.8, 3.1, 3.4. If we calculate this interval, interval 1, 2, 3, 4, 5, 6, 7, 8, 9. Is 9 for, but the interval between 1 and 1.3 is 1 interval. So it's equal 8 interval. We see that it's x. What's f of x? F of x is equal to over square root x plus x. That's f of x is y. Meaning f of x meaning y. So calculate at x equal 1. Put here x1. So 2 over square root 1 plus 1, 2. 2 over 2 is equal 1. That's called y naught. Put x equal 1.3. Substitute here. Square root 1.3 plus 1.3. And f equal 2 over 1.3 plus 1.3 is equal 0.8196. It's called y1. Okay. And because it, I think is complicated to use the calculation, but we have a method on calculator. We will show you in live how to calculate. It's very easy. Only put x1 1.3. How is it? How get that? Y mod and inverse get x. Put the equation 2 over square root x plus x. And each time we calculate, we put x equal, we get all this y. So y1 is first point, y not first point, y1 till y8. Substitute the equation now. So by put the value for each symbol, y0 plus y1 plus all y, and add all this making by calculator, not taking any time. So I trapezoid equal 1.4131. It's approximate to 4 decimal numbers. We explain the composite trapezoidal. What mean by composite? Many points, odd or even. So for trapezoidal, I trapezoid integral by trapezoidal rule equal h over 2. What's h? P minus a over n. Multiply first point plus last point plus 2 the other point inside. And what mean by point is y. How to make the table? We make the table by the calculator and calculate it. We can reach the result. Now the other rule is composite Simpson. We derived before the Simpson for 3 points. Simpson for 3 points equal h over 3. First point plus last point plus 4. So first point plus 4y. We have only 3 points. So first point, second, third point plus 4y. If we have many points, but take care for this Simpson rule only for even numbers only. Must be even interval. If I have odd interval, we can use trapezoidal, but even interval we can use Simpson. So Simpson, 1 over 3, we calculated, we reached it. The rule. What's the rule? H over 3 between brackets y0 plus yn. First point plus last point plus 2 even. What even? y2, y3, y4, y6 plus 4 odd. What's odd? y1, y3 and so on. That's the rule for composite Simpson. Simpson third rule. Example 2 about Simpson. Use Simpson rule. Remember, Simpson rule only for even number of interval. So h equal b minus a over number even, not odd. So use Simpson rule, Simpson third rule, to calculate the approximate value of the integration. Integration, same example, from 1 to 3.4, 2 over square root x plus x dx. By taking 8 subinterval. 8 subinterval, so n equal 8. That's even number, so we can use Simpson. Solution was that. First, calculate h. H equal b minus a over n. B minus After calculate h, make the table. We have h 0.3 and we have how many interval is 8 interval. Make the 8 interval the same like trapezoidal, and the values which we get it also inside the table like trapezoidal. But when we substituting in Simpson rule is different from trapezoidal. We have I Simpson equal h over 3 first point plus last point plus 2 even point plus 4 odd points. What's the points which I said? y0, y1, y2 and so on. So take care to put the name for each y to put it correctly. Another example. Want to integrate from 0 to 2.4 x plus e to power negative x power 2 by the two methods. First method, composite trapezoidal rule. Second method, composite Simpson rule. We can calculate it if by taking 8 subinterval, meaning n equal 8, so n is even, so we can use trapezoidal and Simpson. But if n equals 7, we use only trapezoidal, not Simpson. To solve it, first calculate h. H equal b minus e over n. B is the upper limit 2.4, a lower limit 0, n equal 8, so h equal 0.3. We make the table from x equal 0 till 2.4 by how many interval? 8 interval. H interval is 0.3, so increase 0.3 each step and calculate f of x. What f of x equal? X plus e to power minus x squared. We put it y0, y1, y2, y3, y4, y5, y6, y7, y8. Each one we calculate it, and we know how to calculate it easy by calculator. For the mode and make calculation, we get the results. The first thing by trapezoidal. Trapezoidal h over 2. First point y0 equal 1. Last point yn equal 2.40c2 plus 2 the other point. And make calculate and addition, we make I trapezoid is equal 3.7655. The other method by Simpson third rule. I third, I 1 over 3 is equal h over 3 first point plus last point y0 plus yn 1 plus 2.4032 plus 4 odd plus 2 even. 4 odd, what's odd? y1 plus y3 plus y5 y7 also 2 y even is y2 y4 y6, not put y8 because y8 is last point, we take it before, and addition we make the result y third is equal 3.7656. So difference not big difference. We can also calculate the error for both sides. The error for trapezoidal equal minus h power 3 over 12 y naught double dash. What's y naught? We get y substitute by y dash double dash, put x as 0. Y for Simpson rule, we make the error minus h power 5 y naught triple dash, y naught no fourth dash. Other example, integration from 1 to x log x dx. Also use both composite trapezoidal, composite Simpson third rule, and also take n some interval equal 8. So first thing, we calculate the h. What's h? P minus a over n. B 2, a 1. So 2 minus 1 over 8. 1 over 8, 0.125. We make 8 interval. So beginning, evaluate h. H equal b minus a over n. So b is equal 2, a is equal 1. So 2 minus 1 over 8 equal 1 over 8 equal 0.125. And we make the table. Upper row is equal x, and second row is f of x equal x log x. And we make the table x. First value for x is 1, and increase each step by 0.125. So second 1.125 and 1.25 till the last row column is 2. So calculate by the calculator. Get the calculator. Put the calculator is alpha x. After that log alpha x. Calculate x 1. Put it 1. We get first 0. After that equal x 1.125. Get the result, and so on till the end of a 2 is equal 0.602. That's the table. From the table we can calculate the trapezoidal integration by trapezoidal rule, and also integration by Simpson rule. And if we put, so I trapezoidal is equal 0.2767, I third equal 0.2763. If we make an exact solution, integration x log x, we can integrate it by parts, and we take it, we find the result is equal 0.763. So third, or Simpson third, is more accurate than trapezoidal integral, because Simpson third by the calculation for 4 decimal points equals the exact solution.